So let's start the discussion about production technology being different for different individuals, and that's where we introduce the concept of non-convexity. So what is non-convexity? So think about the production Q being determined by capital in the following sense, that it follows the standard production function only for capital levels above some threshold, right? So this threshold is given uh, um, in the model itself. So this is a constant parameter k lower bar, and so if your capital that you are employing in the production technology is above the threshold, only then you enjoy this kind of normal looking, conventional production technology. But the capital that you have is, if it is below this capital threshold, capital K lower bar, then you get some constant output which is below this its level at K equal to K bar. So basically, for K below K lower bar, as you increase K, suppose you have an output and K space, K in x-axis, output in y-axis. As you increase K up to K lower bar, your output remains at W lower bar. It doesn't change. There is no additional output you generate by investing more capital. So output line is kind of flat up to K lower bar. At K lower bar, there is a jump, and then it's given by A times F of K lower bar, which is bigger than W lower bar. And then as K increases above K lower bar, it increases in a concave way. Okay, so that's the idea, that below K lower bar, below some threshold capital, your production technology is kind of very primitive. You produce some subsistence amount of output, but above some threshold, you sort of move to a much better production technology where there's sort of positive return on investing higher amount of capital. So that's the sort of conventional concave production technology. Why this kind of production technology is called non-convexity? It's non-convex because the set of production possible production levels, which is sort of, you can define it in a set theoretic context. That set is a non-convex set. So all concave production technology gives you production possibilities in the sort of production space as a convex set. If there are these jumps like this based on some threshold, then the production possibility set is a non-convex set. It's not a convex set, and that's why it's called a non-convexity in production technology. So basically, these kinds of production technology where you need some kind of minimum amount of capital in order to graduate to a better production technology where you have a positive return on a higher investment, that kind of technology is kind of called non-convex production technology. So basically, non-convexity implies that poor and rich people may have different access to production technology. So poor people whose initial capital is below K lower bar, for them, they can only generate output of W lower bar. It doesn't matter, having a little bit more capital doesn't increase output, so they can only generate W lower bar from that capital. But if your capital is higher than K lower bar, so suppose you are rich and it's above the threshold, then your output is going to be high, and there is a jump at K equal to K lower bar, right? So that's given by this difference. Okay. So basically, for poor people can only do some kind of subsistence activity. They can only go. They have so little amount of capital that they can't really invest and generate positive return. They can only do kind of manual labor and get some kind of subsistence income. So that's determined by this W lower bar. Okay. Again, the rest of the stuff is same. Okay. So they have same. So suppose to begin with, the only thing that we change is change the production function, introduce this kind of non-convexity here, and let's to begin with allow frictionless capital market. Okay. So poor people can also borrow. They need not just invest whatever little amount of capital that they have. They can borrow at a given interest rate freely from the capital market. If that's the case, then poor people will not produce double lower, right? Because they can borrow and produce as much as the rich people are borrowing. So rich people will invest again K star, because for them the relevant production technology A times F of K, and the amount of capital that maximizes profit is again K star, given by the first order condition here, A times F prime K minus R equal to 0. That's the first order condition. So that's given by K equal to K star. So rich people will invest K equal to K star in production. If capital is freely available meaning that at the interest rate there is no limit on the amount of capital that you can borrow, then poor people will also borrow from the market the additional capital that they need to invest K star, and they will invest K star and get the right amount of output that the rich people are also getting, right? So in terms of their income will consist again of the same pie, the same profit as rich people. So the rich and poor will have the same profit from the production, because they both will invest the same amount, because poor people can borrow. But just that their rental income will be different. For the poor people, the rental income will be R times their small k, whatever tiny little k that they have. For rich people, their rental income will be higher, right? So, but again, the rest of the utility maximization, that's the sort of second step in the process, that again is the same, because they have identical utility function, right? So that we have kept same. So again they have this kind of log Cobb-Douglas kind of utility function. So again kt plus 1 will be this constant s times their income, where income is pi plus r times k, and so again you have a case where is the same exact linear relationship that you got before. Okay, so let me just show you this. You get this same gray line as before. It's the same gray line as before. Okay, which hits this 45-degree line at k equal to k star. Okay, so in a world where there is non-convex production technology but perfect capital market, the outcome wouldn't change, because rich and poor people, it's a problem with production technology associated with lower capital. But if capital market is sort of perfect, then poor people can invest as much as rich people are investing, and then they'll be on the same sort of linear capital accumulation path, and they will both land up at K star, right? So production technology again alone cannot explain why poor people stay poor, because they could have borrowed, right? If that was the only problem. So now let's introduce two problems at the same time. Let's make the production technology non-convex. So poor people, if they if they invest a low amount, then they get the subsistence amount of output. And on top of that, let's introduce this additional constraint that they cannot borrow as well. So even if they wanted to invest as much as the rich people, they can't do that because they can't borrow. Because maybe they have to borrow from the local landlord who's charging such an astronomical amount of interest, that they can't afford it, right? So then they're left with just, poor people will invest only their meager capital and they'll get Q lower bar, Q equal to W lower bar. That's their income. So their income is W lower bar, right? And their preference is same as before. They're again going to invest the same constant S times W lower bar, right? If their initial capital is below the threshold, right? So these are the poor people. So all these poor people will save a constant level of money for capital tomorrow. So their capital accumulation will be a constant number. But for people who are rich, who are above the threshold, they're going to invest again. They're going to fully invest their own capital, right? Why? Because they can't borrow. So they're going to fully invest their own capital, because we are assuming that everybody's capital is these K's are also below K star. So they are also constrained, so they'll invest fully in their capital, and their income is again given by their output, right? So their income is their output because they're investing their own capital only. So profit times your rental on your income is just basically your output. So again, they're gonna accumulate S times the output. Okay. So for K below K lower bar, therefore now there are, what is the capital accumulation path? The capital accumulation path is now this jagged line. So for K below K bar, you have this kind of S times W lower bar, right? So where S, S is beta or by 1 plus beta, that's this line. The moment you cross the threshold, you jump to the better technology, right? Because there is no capital market, so different people are investing different amounts. They're just investing whatever they're born with, their endowment. So the moment you cross the threshold, you get access to this better technology, and so you invest fully there, and you jump to a better technology, which means your capital accumulation also jumps, right? So now your capital accumulation is again this S times pi plus, sorry, this S times your output, right? And your output is again a concave function of K, and therefore your capital accumulation is also a concave function as before, right? So this is similar to this concave, except that this concavity is only relevant above some K star. So suppose there is a K bar here, K lower bar here. So above K equal to K lower bar, it follows the concave line. Below that, it no longer has access to this technology. It has this, it has this subsistence. So basically, there we are enlarging this part of the picture and showing that above K lower bar, it's the same technology, same capital accumulation path as the previous picture, but below this, you have this kind of subsistence, capital accumulation. So now there are 2 points at which this capital accumulation path crosses the 45-degree line. So there is a point here and there is a point here. So there are 2 steady states. So what are steady states? Again, if you have this amount of capital at this cross section, then your tomorrow's capital is going to be the same, because this is the 45-degree line, right? So your tomorrow's capital is same as today's capital at this level. So then your capital doesn't change. You're born, whatever capital you have today, tomorrow you have the same amount of capital, right? So then you are stable. Okay. Same here, right? That this is also crosses the 45-degree line. So here also today's capital is same as tomorrow's capital, but just that these are 2 vastly different steady states. Why they are called steady states? They are steady states because these are also stable, in the sense that suppose you get a bump and move a little bit here, you can check that you're going to follow this line and you're going to come back here. Or if you fall back here, you're going to grow and come back here. So it doesn't matter if you sort of jump a little bit to the left or to the right, you're going to come back to this point, right? And you can check this. Same here. If you sort of fall back a little bit, again you follow this capital accumulation path and you're going to land up again here. Or if you accumulate a little bit more by mistake, then again you're going to follow this capital accumulation path back to here, right? So this is both this point and this point. So KL star and KH star, they are both steady state capital accumulation levels. Okay. So now we have multiple steady states, right? So if you are born with capital which is sort of below K lower bar, then you're going to follow this capital accumulation path. You're not going to go to this side, right? You're going to fall back optimally. This is the optimal path. You're going to optimally deaccumulate and land up here. If your capital is just above K bar, if you're born with this amount, then you're going to follow this capital accumulation path and you're going to land at this higher capital steady state level. Okay, so this is what I mean by poverty trap. That the fact that 2 people are born with different amount of capital, say one to the left of capital lower bar, one to the right of K upper lower bar, they're gonna in turn, even in the long run, they're not gonna converge. In fact, they're gonna diverge. They're gonna sort of end up at two different points on the capital level, capital accumulation, right? So one gonna end up at K lower, KL star, another person will end up at KH star. Okay, so then what you get is that then you get a poverty trap, right? So the fact that there are these non-convexities in production, meaning that you need at least a minimum level of capital in order to get access to this kind of better technology, and if you have this credit constraint, meaning that you are not able to borrow, then for poor people it's a bad news, right? Because they have low amount of capital and they can't borrow to access this better technology. Then they are stuck with, they can't save their way out of their misery, right? So then they're stuck with. So optimally, what you get is that they're going to land up at a low level of capital, uh, 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 whereas the rest are going to land up at a much higher level of capital in the long run, right? So their long run capital is going to be limited. So inequality will persist even in the long run. So that's the idea of persistence of poverty. So we find that non-convexity in production technology and capital market imperfection jointly imply that there are going to be poverty traps, right? That's given by this low level equilibrium capital. So now you can imagine that in a world like this, where different people have, say, at different points on this capital line at KT, which are all below K lower bar, then everybody gets a livestock in the Bangladesh example. Then some people sort of with that additional capital injection jump over to the other side of the K lower bar, but the other people's capital also increase with the livestock, but they still can't cross over. Then you will see that the same capital injection is going to have very different capital accumulation path for the two people, right? Those who are able to cross over to the other side, their capital is going to grow over time and they're going to land up at KH star. And the people who got the cow or the livestock but still are not able to cross that threshold, they're going to deaccumulate and they're going to land up at a low level equilibrium, right? So for them, even though they receive this free capital, is not in the long term going to lead to permanent increase in income, right? Because they'll be stuck at poverty. So these kind of divergence, if it exists, then that will be an evidence of poverty trap driven by this kind of non-convexity in production technology and capital market imperfection. Okay? So hence the point that capital injection may fail to lift everybody up from poverty. It will only lift people up from poverty if they are able to cross over to the better technology thanks to this capital injection. Okay? For those who are not able to cross over to the other side, they are not going to grow to the and reach the higher level capital. That will not happen, right? So there you see that this kind of capital injection need not be always a fruitful policy intervention in a world where poverty traps are very stringent. So that's the sort of analysis of external environment leading to a persistence of poverty. Okay, so that's the sort of theoretical analysis. Let's move to a bit more complicated argument, where we're going to assume that people have the same production technology, sort of conventional production technology. They have perfect capital market, but their preference is a little bit different. Okay, so now let's define the preference. So now I'm going to change the preference. The preference is going to be same for everybody, but it's going to imply different behavior for poor and rich people. So what are the preferences? The preferences now is similar to as before, but we have a kind of a little bit of difference. So we introduce, instead of just consumption and bequest, or tomorrow's bequest is again tomorrow's capital, you can also spend some amount of money on the luxury good, okay, which we denoted by Z. And your utility is again Cobb-Douglas type, but there are these positive constants inside the bequest and luxury good utility. So it's log C plus beta log small b plus capital B plus gamma times log small z plus capital Z, where capital B and capital Z are constant, they are parameters. Okay, and small b and z and small c are the endogenous variable. These are choices that individual would have to choose, would have to make to optimize or maximize you. Okay, beta and gamma are these discount factors. Okay, and these capital B and capital Z are parameters. As before, your income is given by profit plus rental income. Okay, and profit is same as again a times f of k minus rk. I've written a k prime to differentiate own capital or capital endowment, which is sort of given by k upper bar in the previous version. I'm just writing k now, and so the capital that you actually invest in production, I use a different notation, k prime. Okay, so k prime is the capital that you use in the production technology, and k is the capital that you own, and they can be different, right? Because you can borrow. So let's assume free capital market. Uh, 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 so this is kind of um, this is incorrect. It should say that we are assuming no capital market imperfection. Okay, so there is a perfect capital market to borrow capital from. The budget constraint is that your income must be divided across now three things: consumption of the regular consumption good, tomorrow's capital, and some luxury item. Okay, the three things. They all have price one because they are all in the units of the output. What is the marginal utility of consumption? It's 1 by C. What is the marginal utility of bequest? Is beta by small b plus capital B. Marginal utility of luxury good, gamma by small z plus capital Z. Correct? We are first assuming that marginal utility of bequests or saving for tomorrow's capital, so marginal utility of capital accumulation is higher than marginal utility from consuming the luxury good when both are at zero. So when you are not consuming any luxury good or not investing anything for tomorrow, then the marginal utility when both are zero is higher for capital accumulation than for consuming luxury good. So what is the marginal utility when B is zero? It's beta by capital B. Marginal utility when small z is zero is gamma by capital Z, right? So if marginal utility B is higher than mu of Z when both are zero is given by this equation. So basically what this is saying is that there is an ordering. So suppose I want to, currently I'm not investing either on tomorrow's capital or I'm not consuming any luxury good. If I have to spend my first rupee, I would like to spend it on first saving it up for tomorrow's capital, because that gives me a higher utility at the margin than consuming a luxury good, right? So in terms of, so it's sort of, I'm introducing some kind of ordering in preference. I like when to begin with, I would like to save money for tomorrow, then start consuming some luxury. Okay, so that's the order. Now, what is the marginal utility of consumption? It's 1 over C. That's endogenous. C is have to be chosen. But suppose C is very small. Suppose income is so small that your C has to also be very small. As you make C very small, your marginal utility 1 by C goes up, right? When C is close to 0, 1 by C is close to infinity, correct? So your marginal utility of C goes to infinity when C goes to 0. Okay, so when income becomes very small, your marginal utility from consumption 1 by C becomes much larger than both these quantities. Okay, which means that when income is very small, you would like to first consume some essential stuff, right? You must make C positive before you start making either small b or small z positive. So you want to first, when you have a tiny amount of income, then your marginal utility from consumption will be so high, much higher than these two objects. Then you will be first start consuming C, making C positive. First consuming some regular essential items. Okay. So that's what I've written here. Preference is such that when income is low, that condition is important. When income is very low, C gives the highest marginal utility, right? 1 over C would be really high than compared to these two. As income grows, the 1 by C falls because you can consume more and more. So at the margin, that gives you lower bump in utility. And then once 1 by C falls below beta by B, you start investing a little bit on for tomorrow's capital. You want to start saving money up for tomorrow's capital. Okay, and then when that marginal utility falls below gamma by Z, you're going to start consuming the luxury item. Okay, so that's the order you follow, and this order is sort of changes as you continuously increase income. So now it's no longer the case, unlike in the previous example, that your investment or tomorrow's capital or bequest is a constant fraction of your income. That's not true. The fraction changes, right? Initially the fraction is 0. You don't save anything. When income is tiny, you just consume everything because 1 by C is so high, you want to consume everything. But as if you have a higher level of capital or income, then you start want to save a little bit up for tomorrow's capital. Okay, so then you want to save some fraction of your income for tomorrow's capital. But that fraction is going to change as you start increasing income. Okay, and that's something we're going to. That's something we're going to examine. So what you get is that with the same preference, I'm not changing preference, mind you. It's the same utility function, just that the utility function is such, because I have introduced these positive terms here, is such that it introduces some kind of ordering in priority as a function of income. I'm not always going to save money for tomorrow's capital. If my income is very small, I'm not going to save anything. I'm going to only consume because that will give me very high utility. And then only I'll start saving when my income is above some kind of threshold. And as my income goes up, I'm going to save a different fraction of that threshold, and it's not going to be a constant. Okay? Because I have to invest a little bit on consuming at beyond some point. I'll start consuming the luxury item as well. Okay, so if you want to formally do this, what you have to do is set up this Lagrange utility plus lambda times budget constraint. So pi plus rk is your income minus c minus d minus z, right? If you do the first order condition, you will equalize the marginal utilities across the three items that you choose, right? So you will equate 1 by c, marginal utility of c. This is mu of small b. This is mu of small z. So you equalize all these things. From the first equality, you get that b is basically beta times c minus capital B. Right? From 1 by c equal to gamma by small z plus cap z, you get that z equals to gamma times c. So gamma times c minus cap z. Okay. Notice that there is a negative term in each of them, capital B and capital Z. These are parameters, these are constants. And these are consumption amounts, so they cannot be negative, right? So if the parameters are such that this is turning out to be negative for a given C, then it must mean that B is equal to 0 at that point, right? So B and Z cannot be negative, and hence if this expression is negative, then it means that optimal B should be 0, because B cannot be negative, so it wants to, you are stuck at B being 0, you can't go below that. So this optimization assumes that these terms are positive, right? So assuming these terms are positive, you get this interior solution. But if these terms turn out to be negative, then you get this corner solution of B equal to 0 if this is true, or Z equals to 0 if this is true. Now you can substitute, assuming that both B and Z are positive, you can substitute these two in the budget constraint here. So instead of B you write beta C minus capital B, instead of Z you write gamma C minus capital Z, and you calculate. So you have 1 plus beta plus gamma times C, correct? 1 plus beta plus gamma times C equals the income minus capital B minus capital Z. From that you get this expression that your C is this object, okay, when both B and Z are positive, assuming when both are positive. Now if you can have a case when B is positive, Z is 0, but you can't have the other way around. Why? Because of this assumption. Because of this assumption, you can very easily check that, if this is negative, then this is also negative, right? Because if beta by B is such that this is negative, then gamma by Z is smaller than that, so it's also negative. So this negative means this is also negative. So if B is 0, then Z is 0. But you can have a case where this is positive, but this is negative. Meaning, in optimum, you can have a positive B, but optimum Z is 0. Correct? So that's what I have written down here. So we have a case when B is positive and Z is 0. If Z is 0, then you don't have these terms. So basically, instead of substituting Z equals to this, you have to substitute Z equal to 0 and then compute the C, and you will get this C. The gamma and the Z will drop off from here. If both B and Z are 0, then both B and Z equal to 0, right? So both terms vanish, so then you don't have any of these terms here. Both are 0. Then C equal to pi plus RK. Pi plus RK is income. So basically, this is saying that if both B and Z are 0, then you consume the entire income, which makes sense. This is also saying the same thing. So then, basically, the point is that if your capital is very small, right, then this term will be such that both B and Z will be 0. Why? Because if you your optimum value of these will be negative, so this can't be negative, so both will be 0. So then you will end up consuming all your income, right? When capital is so small, then you end up consuming everything, and you don't invest for tomorrow, or you don't eat any luxury food. If your capital becomes a little bit higher, so that's what this is saying. When your capital is very small, then you get bequest 0 because you consume all part of your income. When you're in this range, so that will be true when capital is little bit higher, then you start saving a little bit for tomorrow's capital. You are still not consuming any luxury good. Then your capital, this term is positive, right? Your B is positive here. So this is the expression for B. You can compute this because because you have this expression. You can compute. C. You can plug C in this expression to compute B, and you get this expression. If you plug this C in the previous slide's expression, then you get this B. So in that case, this is B. That's a positive number, but your Z is still 0. And when K is high enough such that you can fund both tomorrow's capital as well as enjoy a little bit of luxury, then this is the amount of B you get, because then your C changes, so your B also changes. Beta C times capital B also changes. Correct? So that's the expression. Now the question is, what are these values of capital at which you have these 3 different cases? This case, this case, this case. I'm just informally saying that when K is small, you have this, you consume all your income. When K is in the middle, you consume a little bit and save a little bit, but don't enjoy luxury. And when K is high, you do all 3. But what are these Ks? You have to identify this range of Ks so that you can compute, right? So by plugging, so for what values of K we have this optimal B is 0, right? So that you get by saying that for what value of k would you get this value to be negative. So if you plug the value of c, this, if you plug this c in the equation, so basically if you want this b to be negative, if this b is negative, then you don't want this b, then you want b equal to 0, right? So that's what I'm doing here. If you say that b is negative, you get the value of k. So basically for k below this amount, this is a constant because capital B is a constant, beta is a constant, pi is a constant, r is a constant. So then this is a constant. So k below this threshold, then your income is so low, your initial capital is so low that you're going to consume everything. Sorry, you are in this territory. You're going to consume everything and you're not going to invest or enjoy luxury. If your capital is just above this, then you start investing in B, small b. You start investing in tomorrow's capital, but you're still not enjoying luxury. So what is that range? That range is determined by cases where Z is, B is positive and Z is 0. So Z is 0 when the interior solution gives us negative value. So that gives us another threshold. So when K is above this but below this, then you have a case when B is positive, you start investing in tomorrow's capital, but you still don't enjoy any luxury. Okay. So this, you have to sort of work through this algebra. Yeah, that's why I said that it would be better if you work on your own using pen and paper. So plug, do this optimization and get these values, and then plug these values of C in these equations to get the expression for B, and then check for what values of K do you get these negative expressions, and you get this one for you have one case here, and you have another case when Z gives you negative expression, then you get another threshold. So basically then you have two thresholds. If you are below the first threshold, then you have so little income, you're only going to consume everything. So your investment is 0 basically. You don't, because you can't have negative, so it will be 0. If it's between this and this, then your investment is going to be positive. And if it's above this, it will still be positive, but it will be a different expression. Okay? And the expression is given by this. So this is B. So instead of B, I'm writing K plus 1. So K plus 1 is 0 when K is below that, the first threshold. So that's given by K Lower. I'm just writing it as K Lower following the paper. If it's between these two thresholds, then it is another expression. And if it is above that threshold, this is another expression. Okay. What happens if I just plot this? I get this kind of line, right? So when K is very low, you have such low income that you consume everything of, all your income, so you have 0 investment for tomorrow. So capital tomorrow is 0 basically. Above that, you have a line like this, capital accumulation path, and then above this threshold, you have a capital accumulation line like this, okay, which again hits it at K star. Now, but again, you see there are 2 points at which, there are now 3 points at which this capital accumulation line crosses the 45 degree at 0, in this middle point here, and at K star, and this high level of capital. This is a steady state. This is a steady state because if you are here, you can see, if you have a high positive amount of capital, tomorrow you have 0 amount of capital, right? So then you are back here. So as long as you are here, even if you are on the left side of this intersection, even then you will see that you will deaccumulate until you hit 0 and you land up here. So this is a steady state. This is a steady state. This is an unsteady equilibrium. This is not a stable equilibrium. If you move away from here, you start deaccumulating and you reach 0. If you just move to the above, you start accumulating and you land up here. So this is, even though this crosses 45 degree line and this is a sort of stable point, this is a steady state. This is not a stable steady state. This is an unstable steady state. So we kind of, that's why we ignore. We are only interested in points which are kind of stable, where small perturbations around it is not going to change any final outcome. You're going to land up again here. So So again, you have these two extreme points. So this is kind of a two extreme. This is that you have zero capital accumulation, but you can make this case a little bit less stark. You can make this intersection here by assuming something a little bit smoother, smoother capital accumulation path on this side. Rather than zero, you can have a positive accumulation in that case. But nonetheless, you have this S-shaped capital accumulation path, right? This is a feature of capital accumulation path that shows up in many of these poverty trap kind of models, where you have this kind of S-shaped capital accumulation, which hits the 45-degree line at 3 points. Two of the extreme points are stable steady state equilibrium. Okay? And so again, you have this persistence of poverty because of this low level equilibrium here. And again, this is again, remember, capital market is again perfect here. They can invest in any as much as they want. So they are investing as much as the poor as the rich people. So poor are investing as much as rich people in their production, but just that their initial capital is so low that their income becomes very low, even with same profit as rich people, because they get very low rental income, right? So their total income becomes very small. So that sort of forces them optimally to choose a consumption that leaves very little for tomorrow's investment, right? And so because tomorrow's investment becomes lower, the poor people earn even low rental income tomorrow as well, and that process leads them to stay at where they are. They can't sort of come out of their steady state, right? So this is a kind of poverty trap which results from the way the preference works. That if you have low income, your preference is such that you want to optimally not save as much, right? And if you are sort of above this threshold, so here the threshold is given by this intersection. If your capital is such that you're above this threshold, you are on this virtuous cycle of capital accumulation, which will land you in a higher level of capital. So again, if you have preferences like this, then even with a perfect capital market and no non-convexity, you can still have poverty traps. And again, just capital injection will not going to help, right? It has to be large enough for you to go over this hump, this specific hump. Let me end by just highlighting this paper by Money et al. In 2013 came out in Science, which sort of highlights some of these other behavioral aspects that can make poverty persistent. So they point out that human cognitive system have limited capacity, right? And so if poor people, since they are much more concerned with how the money gets spent, because they have to be really careful with money. If they overspend on anything, it means that they're gonna not be able to spend as much as on something else that is also needed. So poor people have to be really always be obsessed or occupied with how they spend money on stuff. It can leave much little room in their mental bandwidth to think about other decisions that are also important for them to come out of poverty. Right? So if poor people are constantly occupied with financial calculations and concerns, then their cognitive systems are overloaded with that kind of thought, and that leaves much little room for them to optimally decide, how much education to get, what are the new income earning opportunities, and what are the new skill accumulation opportunities which can get them to a higher, better occupation, etc. Right? These kinds of decisions get hampered, which leads to persistence of poverty. Right? So they are so much involved with their daily decision making of handling money that they are not able to sort of think carefully about these long-term issues. So that they show using two experiments. One is a lab experiment, and the other is a field experiment with agricultural farmers, where they show that farmers have much more cash constrained just before the harvest, right? Because they have spent all their money on buying seeds, fertilizers, paying out laborers. So these farmers are cash strapped just before the harvest, but just after harvest they become cash rich because they are selling the harvest in the market. So financial calculations weigh heavily on them just before the harvest than just after the harvest, and they show that it has the same individual makes much more mistakes doing some kind of simple decision making just before harvest than just after harvest. So sort of showing that this kind of concern with financial calculation puts a cognitive load on people, which lead them to make bad decisions otherwise. Um, and finally, poverty can also lead to hopelessness, lack of motivation, which can change people's long preference. It can make them less forward-looking. Maybe they start discounting future more. If they start discounting future more because they feel hopeless, that can also lead to a much less savings for tomorrow. Right, your bequest will be much lower if you think that you are hopeless about having a better future tomorrow. You're not going to save too much money for tomorrow because you think that there's nothing that's going to come out of that money. So you sort of overconsume your income today and you save much less suboptimally. Suboptimally in the sense that if you sort of if you have this idea of a preference which is under more hopeful circumstances. So in that sense suboptimally, but so in that case that can lead to lack of savings and human capital accumulation. And again, there that can be a reason for paternalistic in policy making by state, because state understands that in these kinds of scenarios people's preferences are getting distorted because of hopelessness. And so the only, if left to themselves, they'll never save as much as they quote unquote should. And so the state can sort of uh, compel them to save more in some sense through some kind of paternalistic investment. Uh, right? So that's good. That's sort of these kinds of arguments are an argument in favor of paternalistic policies. Okay, so we're going to talk about this on Thursday. So let me stop here.